Good afternoon, everyone. Hope everything is okay. All right. I'm right here. I said I was coming. We had to wrangle up the dogs, make sure they got in the room and are nice and quiet because, as you know, loud doggies tend to be very distracting. So, couple of things before we get started. I know a couple of people tried to access activity 82. My bad. I put the activity in, thought I attached the sheet, realized a few minutes later that I didn't, but by that time, a few people did try to access it and were unable to do so. So basically, I put it in, so you should be able to access the assignment and do the work. Okay. Also, I did put in the retake for the test. Let me let you know how that works. When you do the retake, it's like taking a brand new assignment. Okay, it's not in the same column. So when you look at the grades, you're going to see the original midpoint and you're going to see the retake. Only one counts. So what I'm going to do is when I see that someone took a retake, I'll compare the score and I'll drop the lowest one. It will not count for your average. If you got the exact same score, then I drop one of them so it doesn't count twice. So you have to give me an opportunity to see that you took the test. So please don't send me messages blowing up Edsby saying, I took my test. I go or have not turned them in at all. So having worked with Edsby to figure out the best way to deal with these issues, it should be working now. I can't check now. I have to check afterwards. I don't know why you guys are lagging. I'm hardwired in. I'm not on regular internet, Wi-Fi. I'm hardwired into the computer. So if you're lagging, it's not me, it's you, because I've got a great signal. So I'll double check it, but I do have a great signal. Okay. Also, what I'm going to do is I'm going to first talk about the activity that we did yesterday. Yes, I do have to take a picture. I do have to post that on Edsby. I didn't have a chance to do that yet. I will be taking care of that. So it's not your Wi-Fi, Gabby. It's unfortunately, they have not been able to meet the demands that need to be met. And as a result, this is what we're dealing with. So, you know, unfortunately, it's the world that we're living in right now. I'm trying to avoid using Wi-Fi so that I can give you guys a better stream. Okay. Anyway, I want to talk about yesterday's activity. The retake closes Friday night, 11:45. So you can take the retake up until Friday night. Okay. Some people have already taken it and they've already seen if they took it early enough that I was able to adjust their grade. I did have to put Edsby down, of course, and get ready for class. So I haven't looked at it in the last hour or so. I do want to talk about yesterday's activities. So after I did this data here with you guys yesterday, I did do a trial from each height with no frictional force on it. So who remembers the difference between the track with this cloth that was providing friction and without the cloth? Who can tell me the difference, what they noticed in terms of how far and how fast the car moved? Any ideas? I know you guys need a moment to type. That's the downfall of using a system like this, but the cloth slowed it down and it did not go as far. It went further and faster without. That is correct. So what does that tell us about frictional forces and speed? Okay. when we're looking at this, how fast something is going. And how does that apply to driving? With the cloth, the cart did move slower compared to without the cloth. That is correct. Okay, how does that compare to driving? And if you can give me an example of what they mean by this. More friction does equal slower speed. That is correct. Anyone else? Oh, by the way, I'll be going over these questions. I haven't looked at the questions yet, but I'll be going over these questions tomorrow. All right, so I'm not getting any responses to this question. If you're driving, okay, if you're in a car and you are driving to okay, who is this? Whoever Captain Savage is, if you're not monitoring your comments, I'm gonna have to boot you. So, activity 82, I'm gonna go in and check. I will get back. Sheet is showing up. Are you not able to see the worksheet? Is that what you're telling me? That you're not able to see the questions? Because the questions are in there now. I went in and I was able to click on it and look at the questions. If you looked about an hour or an hour and a half ago, I know they were not there, but I did fix it. Driving on a different surface affects the speed of the car. That is odd. I will take a look later. Okay, so driving on different surfaces does affect the speed of the car. So if you're driving in the rain versus if you're driving on a dry, sunny day, what does that do for you? So if you're driving in the rain, what does that do to the frictional forces? Does it increase or decrease them? Rain makes the road slippery, so there is less friction. That is absolutely correct. Since rain does decrease the frictional force, it makes the road slippery. Activity 80 was posted last week. We've actually already gone over those questions. 80A we're going to do today, so I haven't posted those questions yet. I just posted the reading so you guys can take a look at it. So, when you look at the speed versus frictional force, the speed versus frictional force, as you decrease your friction, you increase your speed. 80A we haven't done yet, so I didn't post the questions yet. I'll be posting those after class. Okay, so when you're driving, they tell you to slow your speed during rain because since the frictional force is lower, your speed decreases, your speed increases, you can't slow down as fast. It also increases your stopping distance. So as you apply the brake, increasing your stopping distance causes you to get into an accident much faster. Does that make sense? All right, guys, there are people here who probably are not in our class. If you are not going to follow our class guidelines, we're going to have to boot you out of our class. Okay, this is a class that we're actually teaching for content. So if you can't behave yourself, I'm going to ask you to leave. As I mentioned, I posted the questions. There seems to be an issue with the post. I will post those questions later. I can't do it in the middle of a stream. So now, does anyone have a question on activity 82 that we did? Hey, Jake. Okay. We'll go over those questions tomorrow. All right, that's it. I'm done with this. Excuse me 1 second. Since there are individuals that want to act up, unfortunately, in order for us to be able to do what we need to do, I have to remove some users. Now, I apologize for that. So, okay, looking at the effects of gravity, we're going to be going back to 80A. Okay. So, no, I'm not expecting you to do the anticipation guide. If you actually read the assignment that I posted, I'm going to ignore the anticipation guide. I put the reading there to help you when you do the questions if you need to go back and look at it. So don't worry about it. Okay, so looking at the direction of gravity, gravity is a force that pulls any two objects toward each other. You're familiar with gravity as a force that pulls things down toward the Earth, but when considering Earth as a planet, which direction is down? Looking at the diagram at the right, which shows people standing on the surface of the Earth, down is a direction, is different directions at different locations on the surface, but down is always the direction towards the center of the Earth. So I'm actually going to take a picture of this data because I need to erase it. And then I'm going to actually do some diagrams on the board. So if you give me 1 second. Okay, so if you're looking at something like the Earth, and when we look at down, okay, automatically we look at something like this. But the center of the Earth being here, Florida is close to the equator. So for us, down actually looks like this, because down for us points towards the center of the equator. Okay, so down is any direction that points towards the center of the Earth. Okay, so, and gravity always pulls towards the center of a point. That's why all planets, all satellites appear spherical. Okay. Now, the data is for yesterday's lab. The lab that we did yesterday, activity 82. So, now, looking at the strength of gravity, mass, and distance, guys, this concept is very important. The strength of the force of gravity between two objects depends on two things. It depends on the mass of the objects, and it depends on the distance between them. So, the law of gravity states that all things with mass exert a gravitational pull on other objects with mass. The more mass an object has, the stronger it pulls. The Earth is the most massive object near us, so it has a strong attractive force. That's why things fall down towards the Earth, specifically towards the center of the Earth. So, sorry, unfortunately, there are users that are continuing to not follow rules, and as a result, I have to remove them. Now, moving on. So, when we're looking at, I don't know, but I'm having a real issue with this person here. So, and I will keep blocking that person until they're gone. So if I have to stop, I apologize, but we're not going to have people here doing things that they're not supposed to be in. Okay. Now, you have a gravitational attraction to everything around you. Okay. So if you look at, for example, the chair you're sitting on, or whatever you happen to be holding in your hand, or whatever happens to be around you, there is a gravitational attraction between you and that item. However, when you don't experience a gravitational attraction between you and that item, because the gravitational attraction between you and Earth, which is the most massive thing around you, is much stronger. So the gravitational attraction between you and anything else around you is negligible compared to the gravitational attraction between you and the Earth. Okay, so now, as strange as it may sound, while an object pulls on an object near it, the object also pulls on Earth. When an object falls to the ground, even a paperclip, for example, Earth is being pulled towards a falling object. This is because the falling object has mass, and any two objects with mass exert a gravitational force on any other object. Okay? In case of an object falling to Earth, however, the Earth moves much less than an object does, because Earth has so much more mass than the falling object. The force of gravity near other planets is different than it is near Earth, because each planet has a different mass. An object's weight on Earth is the pull of gravity between it and the Earth. If an object is on another planet or moon, it will weigh the force of the gravity between it and the planet or the moon. So, let me go ahead and explain this in language terms. First of all, there are a couple of things I want to discuss. If you look at two objects, okay, and this is actually an important formula that you guys are going to need to know. Yes, Rosie, what's the matter? Who is this? All right, yeah, you can go to, let's go ahead and just do that. Okay. All right, so there was one person whose message was hidden. Moving on. So if you have mass and distance, okay? So you can have two objects that are the same size, okay, here, and those same two objects here. These two objects will have a lower gravitational pull than these two objects. Yeah, please don't use usernames like that in here. They're inappropriate. Now, so, but if you have two objects that are large, let's say, and they're far away from each other like this, and these two smaller objects, for example, are closer to each other, even though these are closer to each other, depending on what the distance is, these two objects can still have a greater gravitational pull because not only is the distance a factor, but mass is a factor as well. That's the reason if you look at the planets, it's the reason why the planets are shaped the way they are. And the mass of the gas giants like Jupiter, Saturn, Uranus, and Neptune, they are so far out because of the fact that they're so massive. If they were any closer, they would slam into other planets or probably get pulled into the sun. It's also, okay, yeah. These comments right here, not appropriate. So this gets us in timeout. Now, so moving on. You know, I might just wind up doing that. I might wind up making trusted students moderators so that they can, because I've already now had to block certain students. And if I see them come back, they're going to be hidden altogether. And I'm tired of interrupting myself to hide students. So, but does everyone understand what I mean here? So gravity and is a factor of both distance and mass. So the further away something is, okay, and the more massive it is, the closer they are, the greater the gravitational pull. The larger they are, the gravitational pull. The further apart they are or the smaller they are, the smaller the gravitational pull. Okay, so moving on. When an object near the Earth drops, it drops towards the Earth instead of towards a more massive object, such as Jupiter and the Sun. This means the force of the gravity must be determined by something more than mass. The farther an object is away from the planet, the weaker the gravitational pull is. So basically, we just went over that in terms of distance. Okay? Now, gravity and orbiting objects. So since Earth's gravity is pulled down towards its center, why don't satellites and even the moon come crashing down to Earth? So close is greater, far is less. That is correct, Christopher. You're right. Okay. Strange as it seems, gravity helps satellites and the moon stay in orbit. Imagine throwing a ball as fast as you can. It might go 30 meters before it hits the ground. The ball curves as it falls because the force of gravity is pulled down as it travels. Next, imagine you have a cannon on the top of a tower in the diagram. Your cannon might go quite a distance before it hits the ground. Now imagine you have a cannon that can fire a cannonball faster. It would travel further before hitting the ground. So what they're trying to show you is the trajectory of objects. Okay? So if you have an object, you're welcome. Okay, if you have an object, for example, if you throw a ball, okay, as that ball is traveling, it initially will travel in a straight line, but it's eventually going to arc down until it hits the ground. Okay, the faster you throw it, the larger the path of the projectile before it begins to curve. The slower the ball goes, the faster it will start to drop. Okay, same thing with the bullet. Okay, that's why distance is very important in understanding the trajectory of a bullet. If you were to fire a gun, okay, that bullet would actually travel quite a distance before it starts to drop. Now, the problem with the bullet starting to drop is that you could be aiming for one thing, but because it's depending on, you know, the rifling and all of the different characteristics of the weapon of choice, it may travel far, it may not travel as far. Okay, so you could be aiming for one thing. Let's say you're shooting at a bullseye, and it winds up hitting the last rung of the circle of your bullseye because it starts to drop down. Does that make sense? So when you're looking at paths, as you throw something because of the gravitational pull, as the speed decreases, gravity starts to take over and it starts to pull the object down, which is why you get this curved trajectory. Baseball players experience it. People who fire weapons begin to experience it, so on and so forth. Okay? The test is the same because it is a district test. However, it is posted in a different column altogether. Okay, the other one is completely closed. So, okay, now orbit is a different thing. Now you're out of Earth's you're out of the main gravitational pull of the Earth, okay, that would cause something to fall to the planet. Basically, when you're in orbit, you found that balance between the two objects where it'll just get pulled around the Earth, like the moon. Okay, so instead of the moon, if it got any closer, it would get pulled towards Earth. If I get any farther out, it would continue to fly in whatever direction it was going in. But it has found that balance where if the Earth is here, it's going to orbit the planet. So that's the difference between, you guys have seen stars. You guys have seen, like what people call shooting stars, which are actually meteors entering into the Earth's atmosphere. Okay, depending on the path of the trajectory towards the planet and how close it gets to the planet, depends on whether something orbits the planet or it enters into the atmosphere and burns up in the atmosphere. Okay? So, I'm sorry to hear that. I really hope they recover. This is a terrible thing. No, I'm not saying it's in a decaying orbit. What I'm saying is, as an object gets caught in the Earth's gravitational pull, depending on its trajectory at the time of it getting caught in the gravitational pull and how far out it is versus its mass. If it's too close, it'll get pulled in. If it's too far away, it'll get pulled out. So as it's moving in orbit, there's a balance there. If something happened, if somehow something caused it to shift, if something slammed into it. Okay, so I don't know who this is, but this is this person is about to get removed. So now, does that make sense? So orbits are based on a delicate balance between distance and mass and allows them to stay in an orbit together. That's also the reason why Jupiter and Saturn have so many moons. The reason they have so many moons is because if you look at Jupiter and Saturn, they're so massive. Anything that got close to them, because they're so far away, got caught in their gravitational pull, because their gravitational pull is actually really, really large. Real fun fact, though, Jupiter is actually considered a small failed star because it was big enough to become a star, but it did not generate enough thermal energy to actually become a star. So we could have had what is called a binary solar system. So now, enough about gravity. All right, so weightlessness. So outside of the solar system, far away from the sun and any planet, the pull of gravity is so small that a 150-pound person would not have any measurable weight at all. So far, no human has ever gone that far. Astronauts orbiting around the Earth are too close to the Earth to experience near zero gravity. A 150-pound person weighs about 136 pounds while orbiting the Earth. Yes, actually, a good chunk of Jupiter's moons are larger than Pluto. There are actually some of Jupiter's moons that are larger than Mercury. Uranus does have moons. They don't have nearly as many moons. as doesn't have as many moons as Jupiter and Saturn. So now, weightlessness. This is one thing I wanted to point out, and this is something you guys should know. If you are on Earth, Earth's gravitational pull is 9.8 meters per second squared. Okay? So if you were to figure out what your weight would be on the moon, it would be 9.8 meters per second squared times your mass. Okay? And it would give you your weight in meters. If you were to go to the moon's gravitational pull, oops, sorry, I can't spell. The moon's gravitational pull is 1/6 of Earth's. And as a result, since the moon's gravitational pull is 1/6 that of Earth's, your weight on the moon would be 1/6 what it would be on Earth. So if you were on the moon, and if you were on Earth and you weighed 180 pounds, on the moon you would weigh 30 pounds. Okay, and that's because its gravitational pull is far less. Okay? So, we have not sent people there. They're working on sending their first people to Mars. It is a 6-month trip, and the thing is, unfortunately, the trip would take so long and people would experience so many changes that they wouldn't be able to come back. Yes, this year's science is combined with math because physics and chemistry is very math-based. Science and math are married. So, at this point, we've actually gotten to the analysis questions. So, the whole point of this was to understand the effects of gravity. I did post the reading for you. If you have any questions, you're welcome to ask me. I am going to be terminating the class shortly. I know, and I really, yes, but that satellite was propelled. I haven't actually confirmed that information. If Russia's bigger than Pluto, I would have to check. I'll be happy to get back to you on that. I don't know. I'll look into that and I'll post the answer on EDSB. So I appreciate those of you that have stuck it out despite the fact that we've had some individuals who have decided that they were going to come in here and act up. Unfortunately, because there are other people in the district who make use of this class, it makes it difficult for me to not have this class on a public domain. But unfortunately, we do deal with the trolls. So as we're seeing trolls, you know, we report them, I'll block them, and we do whatever we have to do to keep going. Okay. Once we get out of here, I will check on activity 82, figure out what happened. I don't know why it's not behaving. I'll take a look. You can, and I will be working periodically to check to see who's done their retake. If you require one, you don't have to do it. Okay. If you require it, and I will, of course, drop the lowest test score. So I appreciate that. No, the Zoom class was much worse. So if you have any questions, I'll stick around once I end the stream for a moment or two to see if anyone has any questions. If not, you're welcome to ask me anything on EDSB, and I look forward to seeing you guys tomorrow.